We're back for an exciting conclusion to stoichiometry and stoichiometry 5. Here I'm going to give you some practice problems for you to take a look at and then some guided solutions so you can see examples of the approach to doing this. So here is your first problem. How many grams of potassium fluoride are produced when 0.72 moles of fluorine reacts with a solution of potassium iodide and stoichiometric equivalent? So get yourself a balanced chemical equation, identify your knowns and your unknowns, check the map, set up your game board, work through the problem, pause the video while you're doing that, and then we'll come back and do a guided solution. So we want to start with a balanced chemical equation, which we have here on the screen now. Also, there are a bunch of different ways to tackle these problems, but one of the things I like to do to help me track through what I need is across the bottom of that equation, I'm going to write what pieces of information I am given in the problem. And then anytime I need a molar mass, I'm going to go ahead and calculate that to start, and I'm going to write that above each substance in the problem. So we need to identify our knowns and our unknowns. So we have that 0.72 moles of fluorine, that is our known, and we want to know how much potassium fluoride is going to be produced. So we're going from fluorine to potassium fluoride. And if we check the map here, we're starting at moles. So we're going to go moles to grams. So just two conversions or a two-step process after your given piece of information. I'm going to set up the game board, starting with moles of fluorine, 0.72. We're going to get our mole ratio in there then, which is 2 to 1, and then that molar mass of potassium fluoride over the number of moles. You are going to multiply across the top. You're going to divide across the bottom. And you should get 84 grams of potassium fluoride. So that's a really good, the slide there anyway is a really good model of the approach to solving these problems. You might have a different system for tracking through that information, and you're certainly welcome to use that system, but this is how I tend to set these problems up to have all information in front of me kind of in a visually useful way. Okay, so here is a problem involving limiting reagents. And so we are looking for the mass of sulfur trioxide produced in a combination reaction between sulfur dioxide and oxygen gas, standard temperature and pressure. Before you work this problem out, and I do encourage you to kind of work this problem out, I want to talk a little bit about the types of limiting reagent questions that you're likely to see. One of them is just identifying what your limiting or your excess reagent is. And so here you're identifying a substance, and so your answer is going to be a chemical formula rather than a number or a measurement. You might be asking for the theoretical yield of one of your products. This is a combination reaction, so there's only one product, but we could certainly have a multi-product reaction in which you would be looking for the theoretical yield of one of those products. And then the third type of question is determining the amount of excess reagent. So you have one substance that you're going to run out of. You have another substance where there's going to be some left over, and this question is asking you essentially how much is left over. This particular problem is a theoretical yield question. What mass of sulfur trioxide is produced? And so since we're given both substances, or we're given information on both reactants, I should say, we need to find a limiting reagent before we can figure out that theoretical yield. So pause the video, see if you can work through that, given all the information from the last video. And then again, when you come back, we'll look at a guided solution. Okay, so here's our setup. Now again, that last problem was asking us to find a theoretical yield, but what I want to do is walk you through using this problem kind of the different types of questions. So let's say that question was just asking to identify the limiting reagent. Well, there's a couple of different ways to go about identifying limiting reagent. If all you're asked to do is to find which one is your limiting reagent, then you want to go from one reactant to the other, and it really doesn't matter which one you pick. So I'm going to start by going from the sulfur dioxide to the oxygen. Um, this is going to be a gram to mole to liter conversion in order to be able to compare what I need with respect to oxygen to what I have. So you're going to start with your given piece of information in the top left, which is the 12.4 grams of sulfur dioxide. We're going to use that molar mass then to convert to moles. We use our mole ratio to do that middle step, 1 mole to 2 mole. And then 1 mole of oxygen gas is equal to 22.4 liters. So you're going to want to multiply across the top and divide across the bottom. And what you find is that it requires 2.16 liters of oxygen gas at STP to react exactly with the 12.4 grams. Well, I have more oxygen than I need. I only need 2.16 grams. I have 2.24 grams. That makes sulfur dioxide my limiting reagent because the oxygen is in excess. I have more than I need. Again, it doesn't matter which reactant you start with. So I can flip this thing around and I can start with the oxygen gas. And so if I start with the oxygen gas, that's going to be a liters to moles to gram conversion. And here's the setup. So you're starting with that 2.24 liters of oxygen. You're dividing by 22.4 liters. You got your mole ratio in there 2 to 1. Again, notice it's flipped because now we're going from oxygen to sulfur dioxide. And the 64.07 grams of sulfur dioxide in 1 mole. And when you run that calculation out, you find that you need 12.8 grams of sulfur dioxide to react complete with the oxygen. You only have 12.4. Again, you're going to run out of the sulfur dioxide. It doesn't matter which one you start with. You have to compare what you need to what you have, and you will be able to figure out the limiting reagent either way. Okay, so the second type of question is the how much product question. And so there's 2 ways to sort this one out. You can do either of the 2 calculations that we did in the last slide, which will identify your limiting reagent for you. Once you identify your limiting reagent, you have to use your limiting reagent to figure out the amount of product. You can only produce as much product as your limiting reagent allows. So once I know sulfur dioxide is my limiting reagent from working either of the 2 calculations on the previous slide, I'm going to go grams to moles to grams from sulfur dioxide to sulfur trioxide. Here's the setup for that. It's 12.4 grams of sulfur dioxide divided by the molar mass. Our mole ratio is 2 to 2. Of course, if you want to reduce it and write 1 to 1, you can. I usually, in my game board, I put whatever coefficients are in the chemical equation rather than reducing. The calculation will take care of that. And then the molar mass of sulfur trioxide at 80.07 grams. So you're going to multiply across, you're going to divide across the bottom. You should get 15.5 grams of sulfur trioxide, and so that is your theoretical yield of sulfur trioxide. If you had not done either of the 2 calculations in the last slide, if you didn't know sulfur dioxide was your limiting reagent, then in order to figure out the amount of product, you could run both calculations to product, sulfur dioxide to product, and oxygen, liters to moles to gram, to your product. And so you're going to set up that game board, 2.24 liters of oxygen divided by 22.4 liters, get your mole ratio in there, and then again the 80.07 grams. And what you end up getting there is that oxygen would produce 16 grams of sulfur dioxide. Whichever of these 2 calculations gives you the lower number is your theoretical yield. So at this point, if you are given the how much product or the theoretical yield question, you have 2 options. You can work from one reactant to the other and figure out your limiting reagent, and then calculate your limiting reagent to product, but that's 2 game boards. Or you can take each reactant to the product and pick the lower number, and that again is 2 game boards. It really doesn't matter which way you go about it. You're going to have to do 2 calculations in order to figure out theoretical yield or amount of product. All right, now here's the last question. This is the amount of excess reagent question. So this is the same slide from 2 slides ago. And essentially what we're looking at here is if I go from sulfur dioxide to oxygen gas, and I identify sulfur dioxide as my limiting reagent, I'm in great shape. And what I'm going to do from there is I'm going to say, hey, I need 2.16 liters of oxygen, but I have 2.24. I have more than I need. How much is going to be left over? Well, I'm going to subtract the two. 2.24 liters is how much I have, minus the 2.16 liters is how much I need, and that's going to produce an excess of 0.08 liters. However, if I had picked oxygen as my starting point, I would have found out that sulfur dioxide is my limiting reagent, and you can only solve the excess question by going from limiting to excess. So if I'd started with the second calculation, I would have to then go back and do the first calculation. And most days you're flipping a coin. You're guessing on what your limiting reagent is. And if you guess wrong, you have to do 2 calculations. If you guess right, you only have to do 1 calculation. And so that last 3 slides really kind of wraps up all of the different ways to go about calculating a limiting reagent question, depending on what information is asked of you. You have some choices when you're faced with one of these questions, so you kind of have to just decide how you're going to tackle it. And that wraps up stoichiometry. Good luck with your practices, and let me know if you have any questions.